So where we left off last Thursday is we're in this chapter 6, and it's two-way tables. Now remember, the two-way table, that's a way of classifying the individuals in your data set by two categorical variables. I'm going to remind you of a couple things. You've got a row variable, that's how the rows are chopped up. You've got the column variable, that's how the columns are chopped up. And then I gave you, whether it was the one we were looking at from the other day was one of the variables was their sex and education. I'm looking at table 6.1 on page 164. And the other variable was the preferred lifestyle or the lifestyle. So I was telling you that was a 4x3 table because there was 4 rows and 3 columns. I'm not counting the totals of the rows or the totals of the columns, right? We had talked about, I just want to remind you of this. What we calculated last Thursday was marginal distributions from a two-way table. Always. Let's do it like this. One for each variable. Whether we're looking at the rows or we're looking at the column, there's always a marginal distribution for the row variable. There's a marginal distribution for the column variable. And the thing I want to focus in on is if you're looking at the row variable, then it was the row totals over the table total, right? If it was the column variable, it was the column totals over the table total, right? Because if you'll go back and look, we had worked the one, and I'm thinking we did the one for preferred lifestyle, right? And I kept using 1,012 as the denominator, right, in my little fractions when I go to calculate the percentage. The reason I'm pointing that out to you is look, when you're working with a two-way table, what it comes down to is the two-way table gives you the count, right? It tells you how many individuals fell in each one of the cells. And then what do we got to do? It depends on whether you're looking at these marginal distributions. What numbers do we use to make up our fraction to calculate or to make up our proportion to calculate our percentages? All right? So that was what we did last Thursday. Now, the last thing I left you with is this idea of conditional distributions. Now look, the reason we're looking at any of this stuff is because we've got two categorical variables and we want to know if there's a relationship between them. Marginal distribution tells you nothing about the relationship. It just tells you about each variable separately. All right? So when I'm thinking about conditional distributions, and let's say I have an R by C table. Now that's just me writing down, okay, I've got so many rows and I've got so many columns. The last thing I wrote last Thursday was, when I'm talking about these conditional distribution, there's always R plus C conditional distributions. There's one for every row. There's one for every column. Right? So for every row there can be a conditional distribution, and for every column, so there's R plus C of them. Now, here's the thing. There might be R plus C of them, but these are of them. In other words, when you're looking at the ones for the rows, they stay together. And these, when you're looking at these for the columns, they stay together. You don't take a conditional distribution from the row and a conditional distribution from the column and start telling me something. You either take all the rows together or you take all the columns together. Okay? Now, here's what's going to happen. Rob, can you fix it so I can see you folks instead of this outline I'm looking at?
Is that better, Mike?
Thank you, bud. Use these for relationships. Now, I'm still going to work with that table from last Thursday. I'm still going to work on page 164, this table 6.1 here. All right? What I want to do is this. You're not using the table total now in your fraction. You're not using the totals of the rows or the columns in your numerators, right? So what I want to do is this. If I look at this table, right, and just forget any conditional distribution, here's what I want to know. What percentage of these individuals in this table are women with no college and have a job outside the home? Does everybody see there's 81 of those, right? I just want to make sure that we can read the table correctly. And then how many in this table are men with no college that would stay at home and care for house and family? Everybody see there's 32 of those. Okay? Now, what about this? What about if we do this? Out of the women with no college, in other words, just focus your eyes on that first row. What percentage of those individuals will set a job outside the home? Now, you got to pay attention to my language here, right? So what I know is I want to know out of the women with no college, that's the group I'm looking at. That's the row I'm fixing here. Out of that group, how many of those, what percentage of those set a job outside the home? So I'm looking at job outside the home. Given a woman with no college. Now, I'm going to circle a word here for you. The key word here is given. We're only looking at women with no college here, and I want to know out of that group, out of that row, what percentage of those people said a job outside the home, right? So I want to calculate that percentage. How many people are we looking at? We're only looking at the first row because we know that we're looking at the women with no college. How many people's in the first row here? Well, there are 195. Out of that group of 195 people, how many said a job outside the home? 81. What's that percent? What's that proportion? What is 81 divided by 195? Well, what? Yeah. Guessing, right? Oh, 0.415. So that means 41.5% of the women with no college said a job outside the home. I just wanted to do one. I just want to get you used to reading that table like that, right? Okay, I want to know what percentage said a job outside the home within the group of women with no college, given that we're looking at the women with no college. There's 81 of them. There's a total of 195 that had the women with no college, right? And then that turns out to be a proportion of 0.415 or 41.5% there said that out of that group, right? We're only looking at that group. Look, all I see is the first row. Okay? Now, that's just one little number out of a conditional distribution, right? So what I would like to do is I would like to look at just that first row, women with no college, and I would like to look at the distribution of lifestyle for that group. Okay, here's my language. I'm going to fix the first row, and that's all I'm going to look at. And now I want the distribution of our variable preferred lifestyle. So here's the language. I want the conditional distribution of lifestyle given the women with no college. Now again, that tells you what group you're looking at. And I try to always use that word given because that's the clue. So all I'm going to do is based off of what I see in that table, I'm going to give you the conditional distribution because we're only looking at the first row there of lifestyle for the women with no college. Now, when I go back here and look at this table, there are three different choices for lifestyle here, right? So, I mean, you're still going to have that distribution. You're going to have outside the home for a job. You're going to stay home, take care of the family in the house, or no preference. There are three different possibilities for lifestyle. The catch is I'm only looking at the first row. So let's do this. There's 195 in the first row. That's going to be your denominator. Okay. Now, in the group with women no college, how many of them had a job outside the home? 81. We'll figure that. We already figured that one, right? That was 41.5%. Now, out of the group with no women with no college, how many said stay at home and care for the house and family? Out of the women with no college, how many said no preference? Now, we know this one here is 41.5%. What's 104 divided by 195? Anybody? .53. Percentage be 53.3%. And then what's 10 divided by 195? I mean, I can guess it should be 5.2. Does anybody know how I knew without having a calculator? You understand those three got to add up to be 100%, right? Because every one of these that had women with no college picked one of these three lifestyles, right? So right there, that's the conditional distribution of lifestyle, given that you're only looking at the group women with no college. Can I do 4 more of these? 3 more of these? Was there anything special about the first row? Could I have done the second row? Could I have done the third row? Could I have done the fourth row? I could have done any of these, right? There are 4 conditional distributions of lifestyle given the particular sex and age. The sex and education level, right? Let's do another one. Let's look at the conditional distribution of lifestyle, your column variable, given okay, well, let's look at men with no college. That tells you what to fix. That tells you what group you're looking at. Now, you're still looking at lifestyle, right? So there's still 3 possibilities. The job outside, stay at home, no preference. So instead of looking at the first row, you're going to look at the row with men with no college. You're going to look at the third row. And how many people in this table are men with no college? There's 126 of them, right? So I'm going to take 126 as my denominator. Then in that row, the men with no college, how many said a job outside the home? 92. How many said stay at home and care for the house or family? A house and family is 32. How many had no preference in the men with no college? So what is 92 divided by 126? That's kind of high. 73 exact. What is 32 divided by 126? What was it, 25.4? And then 2 divided by 126 must be everybody left over. Am I close? The reason I know that is because everybody that was a men with no college had to pick one of those 3 lifestyles. They got to add to 100% or at least be off by a tenth, since that's the way we're rounding here. So now I had 2 conditional distributions for lifestyle given women with no college and men with no college. There's 2 more we could have done, right? There's 4 for the rows where you fix the row. right? There's 4 conditional distributions of lifestyle where you look at each row separately. Okay, I got to do one more. Let's look at the conditional distribution of sex and education given that the individual said job outside. Okay, so this is a flip-flop now. See right there? You're not looking at a sex and education level. Now you're looking at a lifestyle choice. I'm going to fix a column. I'm going to look at the column where they said the job outside, right? So I'm looking for the conditional distribution of sex and education, the row variable, given that we picked a column to look at, given that the individual said job outside. Now, how many different percentages I got to pick? I calculate here. I got to pick one for. I got to do one for every one of the rows, right? So I've got women, no college, women, college, men, no college, men, college. That's the 4 rows, right? That's the 4 values of sex and education. Now, for all 4 of these, what number are we going to use for the denominator? You're looking at the group that said a job outside the home. You're looking at that column. How many people in this table said a job outside the home? There is 645. Now, you're looking, now when I'm looking at the table here and you're asking me for conditional distribution of sex and education given this particular lifestyle, job outside, I mean, I could do this. All I see is that first column. The rest of the table is irrelevant to me. So, in this table, how many people said job outside are women with no college? 82. How many are women with college? 173. How many are men with no college? 92. Men with college? Then we pull the calculator out and we start calculating proportions, and then we move the decimal place and we get the percentages. Anybody? Women, no college in that group? 12.7%. The women with college? 26 point something? 26.8%. The third one, men with no college, and I'm only looking at the ones that said job outside the home. What'd you get there? 14.3. And then just go ahead and do the last one for me, the 299 divided by 645. 46.4%. Should those 4 numbers add to 100? Yeah, because no matter what your sex or education level, right? You had to fall in one of those. Now, the reason I did one of those, you understand that there's 4 for the rows, where you're looking at the conditional distribution of lifestyle given the different sex and education. You understand there's 3 for the columns, where there you're looking at the conditional distribution of sex and education given the different lifestyle preference. Remember I told you, if it was a 4x3 table, there should have been 7 conditional distributions. There's 4 in this hand. We did 2 of them. There's 3 in this hand, and I just did 1 of them. Okay? Now look. The conditional distributions are using the numbers in the body of the table as the numerators. They're using column totals or row totals as your denominators. Marginal distribution use row totals or column totals as your numerators and the table total as your denominator. Look, I'm just trying to help you out on getting where in the hell is the numbers coming from, right? What am I using? That is the total of the first row. That is the total that said job outside. Right? So, there's all kinds of conditional distributions. Now, well, hell, in this case, there's 7. All right? Here's what I wanted to do. Okay? I mean, I can make graphs out of all this stuff and all that kind of stuff. Here's what I want to give you. And I'm going to come and we're going to work a few homework problems out of here, all right? Look, I know we're used to seeing bar graphs with categorical variables, right? And that's fine for the marginal distributions. You can make a bar graph of this one or this one. It's just not a straightforward bar graph here. We're going to have two choices. We're going to have something called a cluster bar graph, where we're looking at the conditional distributions of what we're looking at, or a segmented bar graph, and we're looking at conditional distributions. The reason we're interested in these is not just so we can go through and say, oh, well, hell, there was 4 this way and there was 3 this way. We're looking for the relationship between the two categorical. We're looking to see if there's a relationship between the two categorical variables that we're looking at. So, here's the way I'm going to give this to you. All right, here's my hint with all this, how I attack these problems. If nobody tells me what ones to look at, this is my hint. And I'm thinking about it like this. Suppose we have this explanatory and response. You know, where we think one explains or influences the other. Here, we think one categorical helps explain or influences the other. All right? What we want to do is we want to compare the conditional distributions, right, which is what we just talked about, of the response variable for the given values of the explanatory variable. That's the magic word. So if your explanatory variable is the row variable, you will fix the rows and look at the conditional distributions of the column variable, because that would be your response. If it turns out your explanatory variable was the columns, you would fix the columns and look at the conditional distributions of the row variable. It depends on which way we... Now look, if I don't have thinking that one explains or influences the other, hell, just pick a set of conditional distributions. Pick the ones for the rows or pick the ones for the columns. See what that tells you. This problem we've been working with here about the person's sex and education level and their preferred lifestyle, I got this weird thought that a person's sex and education level may have something to say, may help explain their preferred lifestyle choice. Okay? So if we were going to do anything here with the problem that we're looking at, and what I'm looking at is this table 6.1, and I'm looking at that and thinking, okay, so I want to see if there's a relationship. Do I think one helps explain or influences the other? Well, yes, I do. I think that the person's sex and education level will help explain their lifestyle choice. Right? So I'm treating their sex and education level as the explanatory variable and their preferred lifestyle choice as the response. So what am I supposed to look at? I'm supposed to look at the 4 conditional distributions of lifestyle given the sex and education values. there are 4 of these. That tells me there's going to be 4 conditional distributions. So in other words, I got a pile of stuff to calculate here. There's a pile of percentages to calculate. Remember, for every one of the different sex and education values or levels or rows, there are 3 percentages to calculate for lifestyle, right? Didn't we do 2 of them? That's where we started with, right? We did the conditional distribution of lifestyle, given that the person was a woman with no college. We did the conditional distribution of lifestyle, given that it was a man with no college, right? We did those 2. There was 2 others to be done there. Now, we could stand here and do them. Okay, if you want me to do the one for women with no college, I'm going to fix that row, and I'm going to do 173 divided by 303, 115 divided by 303, and I'm going to keep going, just like I did the other ones. All right? So the book has done this for us on page 167. You notice the women of no college was the 41.5%, 53.3, and 5.1. We did that. The men with no college was 73, 25.4, 1.6. We did that. They did the other 2 for us. They did the women with college and the men with college. And it says the percents in each row should be 100% because you're looking at the 4 conditional distributions of preferred lifestyle given the sex and education value. You fixed the 4 rows there. It says, in fact, the percents add to 99.9, 100%, or 101. We rounded to the 10th. I don't freak out being off by a 10th. The conclusion here, for this particular group of individuals, the sample, men are more likely to prefer a job outside the home. Is that true? So here's what you're trying to do all at one time. There are 4 conditional distributions there. They're running across the rows. Yeah? Does everybody see that the men, college or no college, is in the 70% that said job outside? You understand why they're telling you that men are more likely to prefer a job outside the home based on what we're seeing in this table? The men with no college said 73% said job outside. The men with college, 77.1% of them said a job outside. Right? So men are more likely to say a job outside. It also says whether they went to college or not. Adults who attended college are more likely to prefer a job outside the home. Now, look at the ones where the women that went to college and the men that went to college. Is that a true statement? Yeah. Well, let me ask you this. Which group is more likely to stay at home and take care of the family and home? That's the women with no college, right? Because in that group, there was a higher percentage of them that said stay at home. I don't even pay any attention to the no preference. Hell, they're all small percentages. So what I'm asking you is you've got 4 sets of numbers. You've got 4 conditional distributions of lifestyle, 1 for each sex and education value. Do those 4 distributions look different to you? See, here's the deal. I'm almost done with this chapter, but we're not done with this idea of looking at a 2-way table and telling me if you see a relationship or not. It's going to be one of the last things we do this semester. We're going to come back to this again. What I'm asking you at this point is, you're looking at these 4 conditional distributions. Do they look the same? And what I mean is, are the percentages the same for each one of the different lifestyles? And the answer to that question is, you understand if they were the same, would it make a difference on the sex and education level, on what they preferred? The answer would be no. Right? If they're different, it's trying to tell you, oh, well, the sex and education level made a difference on what they preferred. Lifestyle, right? So when I look at this, if I look at the job outside the home, it's 41.5, 57.1, 73, 77.1. Well, hell, those are different, right? They're off by a bunch. And I definitely see that men are more likely to say a job outside the home. Yeah? And then I see the other one. Well, go to the next one, the stay at home. It goes 53.3, 38, 25.4, 20.9. Are those different? Yeah, there's a big difference there. And what's the big difference I see? Oh, women with no college were more likely to say stay at home. Actually, women with college were more likely than men to say stay at home. Yes? Looking at that, it appears women are more likely to want to stay at home than the men are. Yep. What group was the least likely to stay at home? Hell, that was the men with college, right? That's 20.9%. What I want to get stuck in your head is those distributions are different. Now, they're not going to be exactly the same numbers, but if they're off 1 or 2 percentage points, hell, that's nothing. But when we range from jobs outside the home at 41.5% up to 77.1%, hell, that's 35%. That's a big difference. So there's something up here, right? There is a relationship between a person's sex and education value level and their preferred lifestyle. It appears men prefer to get a job outside, even more so than women do. And the other thing that catches my eye is, well, it appears women with no college prefer to stay home. Yeah? Remember, we're trying to say something about the relationship. Just looking at the percentages and saying, well, here they are. No, you got to look at them and see how they're different. That's what I'm doing here for you. Right? I'm looking at this and seeing how this is different. Now, I'm going to go back to this right here. If nobody tells me anything, that's the conditional distributions I want to look at. Because remember, there's always the set for the rows, and there's always the set for the columns. And I don't know if I warned you today, but you don't take one from here and start telling me anything. You either take all of these from the columns, or you take all these and you start telling me something. Here we took all the ones from the rows, right? Remember, we fixed a row and looked at the conditional distribution of lifestyle. Now, here's my other thought, all right? Is I want to come over here to your homework. Because to me, the only thing that's left is a little thing about lurking variables. And what I want to look at is, I want to look at problem 619 on page 175. Okay? And what we have here is this. Resistance training is a popular form of conditioning aimed at enhancing sports performance and is widely used among high school, college, and professional athletes. Although its use for younger athletes is controversial. A random sample, in other words, they just chose some random people here that was doing this resistance training. Of 4,111 patients between the age of 8 and 30 admitted to U.S. emergency rooms with the injury code weightlifting was obtained. Now, that's a table. You see the two-way table there? Right? And it says these injuries were classified as accidental if caused by dropping your weight or improper equipment use. I'm assuming if the accidental ones are from dropping the weight on your foot or improper use of equipment, what would non-accidental be? That's where you were being an idiot and trying to lift too much. That would have been your injury, right? It says the patients were also classified into 4 age categories, 4 age groups, 8 to 13, 14 to 18, 19 to 22, and 23 to 30. Here's a two-way table. So your row variable is the age group, right? They're treating it as a categorical variable. The column variable is how was your accident classified? Whether your injury was classified, accidental or non-accidental. Everybody okay with that? All right? It says, compare the distribution of ages for accidental and non-accidental injuries. Now, you're going to compare the conditional distributions of age given the type of injury value, right? Whether it was accidental or non-accidental. So what are you going to do? You're going to fix the columns here, right? This is where you fix the column. You're going to take a look at the conditional distribution of age given accident, an accidental injury. You're going to look at the conditional distribution of age given a non-accidental injury. You're going to fix the columns here, and you're going to look at the distribution of age group. Okay? That's what I want to do. So for 619... Now, you know I'm not going to do this by hand. All right? So in 619, I understand the way they're saying it. I want the two conditional distributions of age given the type of injury. Does everybody understand why I wrote a 2 there? There's 2 types of injuries, right? So there's a conditional distribution of age for accidental injuries. There's a conditional distribution of age for non-accidental injuries. Now, let me ask you this. In each one of these conditional distributions, how many percentages are we going to calculate? Does everybody understand why I'm telling you 4? There's 4 different age groups. Okay? So, now, that's the way a two-way table comes to us a lot. They didn't add up anything for us. They didn't give you the the row totals or the column totals or nothing here. All right? So here's what we're going to do. Okay? Look, I messed with the problem about lifestyle and sex and education level. I showed you how to calculate all these by hand. All right? And so I'm going to come here. And there's a file here, and the file going with this is lifting. Yes? So I'm going to go to Open Worksheet. Now, that's that two-way table in a sense. It's not laid out exactly like that, right? The first column is a different age group. The second column is the type of injury. But the third column is the count there, right, on how many people we're looking at there. Now, just so I get all my stuff laid out here correctly, all right? I'm going to go to Graph. Yeah, I'm going to go a little slow here so we can get all this correct. Graph, bar chart. Now, you remember, you don't have every individual and their age and the type of injury, right? Somebody's actually summarized things for you in the two-way table, in the book, and in the way they have it laid out, it's values from a table, right? Now, you don't want a simple one here. You've got two choices. It's either a cluster or a stack. I don't care which one you give me. I mean, on the test, I might give you one or the other. They're the same. All right? So I'm going to show you the cluster one to start with. All right? Now, it wants to know, what do you want to graph? Well, you want to graph those counts, right? We want to graph the percentages. So I'm going to put count there. Okay? And let me just check to make sure I get this correct. Okay? And so it depends. You've got two categorical variables that need to go where it says categorical variables for grouping. And it depends the order you put them in on which conditional distributions you're going to see. Whether you're going to see the ones for the column or whether you're going to see the ones for the row. Well, with this problem, what do we want? We wanted the two conditional distribution of age group for the different type of injury, right? So I'm going to kind of put the injury type first. And then if that actually comes out right, then I'm going to tell you exactly what I did. Well, look, if it don't, then I'm going to flip them for you. Okay? Now, the other thing I like to see here is I don't want to see the counts graphed. I want the bars to represent percentages. So I'm going to go to Chart Options. Anytime I'm messing with one of these cluster graphs, I always come here and I tell it to show Y as a percent. They're telling you, show me the bar as the height being a percent. Okay? And then I always come here and I change this to within the categories. In other words, I want to see each one of those conditional distributions. I want it with inside of there. Not overall, within each one of the conditional distributions. So if I click OK here, now that little move, I do that every time here. Right? I always want to show the height of the bars as percentages. And then if I click OK, there are your two conditional distributions of age given the different types of injury. The one on the left is accidental. The one on the right is non-accidental. So you remember how I did that? I graphed the counts, and then I put in injury type first. Those are the given that part. And then the second variable I put in is those are the ones you're looking at the conditional distribution of, right? The age. Notice their heights are in percents. So what I can see is in the accidental group, around 19 or 20% were age 8 to 13. Around 40% were 18 to 48. Right? I'm reading the heights of the bars for you, yeah? If I took the bars for accidental and I added those 4 bars up, what should they add to? 100%. If I take the 4 bars for non-accidental, they should add to 100. Now, I know we didn't actually calculate it, but you've seen me do this to you before, right? You see, it tells me the bar is the group aged 18. The injury type is accidental. The value is 19%. This one here, 42.2%. Yes, you need to be able to know how to calculate the percentages yourself, but this right here is doing it for you. 42% there. 15.4%, 23.4%. Over here, 3.9%, 4%, 35.8, 20.8, 39.4. So it gives me the four conditional distributions, not only in a picture, but in terms of I can actually see the percentages. Okay? Now, I showed you how to get this to do it. Look, what I would have done if I had to do this by hand, I would have came to this table and I would have had to add the columns together. Like I'd have had to add everybody in the accidental column because I need a total there, right? Non-accidental, I'd have had to add all those together to get that total. And then whatever that total was for accidental, I'd have took the 8 to 13-year-old age group, took 295 divided by that total. And then I'd have just went down that column, right? And then whatever total I got for the non-accidental, for the age 8 to 13, I would have took 102 divided by that total. And I'd have got those numbers I'm showing you right here. All right? Now, surely the God can't be done. Okay, so I showed you how to get a cluster graph, how to show me the two conditional distributions you want to look at in terms of the bars being heights and percentages. The question is, use percents and draw a bar graph. Yes, he did. There it is. What do you conclude? What I want to know is what I'm asking you is you're looking at two conditional distributions of age groups given the different types of energy. Do those two bar graphs look the same to anybody? Oh, dear God, everybody tell me, no, they don't look the same. They don't look the same, right? That's the same way as me comparing those four percentages before, those four conditional distributions. I'm asking you, do they look the same? Hopefully in a picture we can see it better. They don't look the same. The thing I notice here is, check me out, that the age groups 8 to 13 and 14 to 18 appear to have, there's a higher percentage of that age group in the accidental ones, right? And there's a lower percentage of those age groups in the non-accidental ones. In other words, the younger people don't know any better. They start dropping shit on their foot and using the equipment not right. Yeah. What about the older folks that are 19 to 22 and 23 to 30? What do you notice about them? They ain't dropping shit on their toe and using the machine wrong. They actually have non-accidental injuries. They tried to lift too much weight. That's what I see here, right? Is as the age increases here, you're more likely to have a non-accidental injury. On the lower end of the age, you're more likely to have a accidental injury. Right? You're more likely to drop the foot on your weight. Oh, yeah, your weight on the foot, or use the equipment wrong. The older you are, you're more likely to have a non-accident. You're more likely to hurt yourself by actually lifting the weights. That's what they mean by conclude. That's what I see these two conditional distributions as being different. That's one option. You can always make this cluster, and what the cluster graph shows you is, it shows you the conditional distributions that you're trying to compare. Okay? Let's say we didn't want to use that one. Maybe you don't like that one. I got no problem. Let's go back to graph. Bar chart. Values from a table. Now you notice it's one column of values here. Look at my table here. There's one column that has the count in there. It's not a straight up two-way table that's right like in the book. Let's say I want to do stacked. Okay. What's graph variable? It's still the same. I want the conditional distributions of age given the type of injury. So I put the type of injury in first, and then I put the age. I want to see y as a percent. Look, all that stuff stayed exactly the same as the last time. It looked the same. I did the exact same thing. The only difference is, instead of the little pieces being stuck next to each other, they're stacked on top of each other. Anybody shocked that when they put them together, they add to 100%? They were See, there's two conditional distributions of age, one for accidental, one for non-accidental. And then they color code things for you to tell you the different values of the variable, right? The different choices for age group. Does everybody, maybe this one makes the picture a little more clear to you. That when you're younger, you're more likely to have an accidental injury, right? When you're older, you're more likely to have a non-accidental injury. I mean, compare the red and the blue with the red and the blue, and then the yellow and the green with the yellow and the green, right? That's the same story. You're not going to get a different story. It's a different look. That's a segmented bar graph. We can always do that. All right? I want to do one more, just so we get everything worked out here? 6.28. All right? I definitely think this is a place we need to take advantage of software. You need to know how to calculate the percentages on your own. But, if you're going to make a bar graph, this is the way to go. All right? So 6.28 says the following. It's animal testing. Is it right to use animals for medical testing if it might save human lives? The General Social Survey asked 1,152 adults to react to this statement. Here's the two-way table of the responses. So they did two things. They measured their gender, male or female, right? And then they measured their response. Strongly agree, agree, neither agree nor disagree, disagree or strongly disagree, right? There's two categorical variables. Your row is the opinion, and the column is their gender or their sex, right? It says, how do the distributions of opinion differ between men and women? Okay, that's another way for them to ask you. Let's look at the two conditional distributions of opinion given the gender. The reason there's two is because they're either males or females. Yes, I understand there are 5 different choices of opinion here. But I want to look, here's the deal. I know they're saying, how do the distributions of opinion differ between men and women? They're asking you, does the gender have any influence on their opinion? They're treating the gender as the explanatory variable and their opinion as the response. So I should look at the two conditional distributions of opinion given the person's gender. Right? So we come over here. I'm going to find this 628. There. I want you to be aware that that looks just like the other way they put it in. The first column is the person's gender or sex, male or female. The second one is their opinion, went all the way from strongly agree to strongly disagree. And then it was the count of each one. It's not like the two-way table that's in your book, but that's the way it has to work for us to be able to do this. All right? And so I want to go to graph, box plot. Yeah. Graph, bar chart. I want values from a table. And then it doesn't matter. You can use cluster, you can use segmented. It makes no difference. It shows you the same information. All right? I don't know why I picked that one. It may be because it was before the other one. I want a graph count, right? Now, down here, what do I want? I want the conditional distributions of opinion given the person's sex or gender. So whichever one is the given part, that's the one that goes in first. I always go to chart options to make sure I'm showing Y as a percent within the categories at level 1. Then the question is, this is showing you the two conditional distributions of opinion, one for the males and one for the females. Then the question is, do these two bar graphs look the same or do they look different? Oh, these look different. Yeah? What do you notice about the males? If you were a male, you're more likely to say agree. What do you notice about the females? Well, they're more likely to agree, but just not as much as the males, right? I'm looking at the tallest bar you're seeing. They both agree, but the males seem to agree more often than the females. What also do you notice? Look at the strongly disagree. I'm looking at the extremes here, folks. Strongly disagree, the males, hell, did any of them actually answer it? Very few percentage, right? What about the females? There was a higher percentage of females that said strongly disagree. So let me ask you this. Looking at that, they are different. I'm looking at the smallest and the largest. Would it be safe for me to tell you that the males are more likely to agree with medical testing on animals, and the females are not quite as likely to agree? So let me ask you this. Is there a relationship between a person's gender and their opinion? Yeah, I just told it to you. Yeah, there is, right? If you're a male, you're more likely to say, yeah, go ahead. Females, a little hesitate, right? Not quite as strong, okay? That's what we got here. I wanted to do at least, yeah.
Sorry, before you clicked over for the chart and you said
I'm going to tell you what she's saying. It's okay. Go ahead.
if you get those backwards, is it
Yeah,
a
so
huge difference?
you're not going to be able to answer the question, because if I flip-flop those two, you know, and what she's talking about, she's asked me about right here. If I screw this part up, like if I forget, that's why when I first told you that, like if I flip-flop those two, like if I put opinion, well, the deal is going to be is you're going to have 5 conditional distributions, right? And you're going to have the males and females for each one of them. I can probably still read stuff off of that, though, right? I mean, look, with the ones that said strongly disagree, you can see the females had a way higher percentage, right? Now, you remember, I picked it because of the way they told me to pick it. Yeah? You're getting 5 conditional distributions of sex or gender given the different opinions. Yeah. So you'll know, that's the reason I keep writing 2, 2. So when I'm done and I'm looking, that's not what I was looking for. Right? Okay? Yeah, it'll let you know. Now, I'm not saying I can't answer that question with that.
Right.
I'm just trying to be consistent with what they asked.
Yeah.
Yeah.
I just know sometimes you read it wrong.
Oh, yeah, you're all fouled up.
Yeah.
Yeah. Now, the only other thing that's left in this chapter is this actually has a name. And I always like this example. Even though it's made up, I like the example. And there's something called Simpsons Paradox. The only place this little Simpsons Paradox shows up is when you're looking at a two-way table, when you're looking and talking about the relationship between 2 categorical variables. That's a two-way table. Now, Simpsons Paradox, it's a story, and it's a story about lurking variables. Remember lurking variables all the way back to chapter 4? They're hiding in the background. We didn't measure them. So this is a story about lurking variables. Okay? That can change or even reverse a relationship. It may flip-flop from whatever you thought we had. Now, usually, when we're dealing with a two-way table and you want to worry about Simpsons Paradox, this lurking variable here is what it does is you've ignored it and you've combined groups that shouldn't have been combined. All right? So I've got this example 6.4. All right? And it says this. Accident victims are sometimes taken by helicopter from an accident scene to a hospital. True. Helicopters save time. Do they also save lives? Let's compare the percents of accident victims who die with helicopter evacuation and with the usual transport to hospital by road. Here are hypothetical data that illustrates a practical difficulty. Now look, there's a two-way table, and it's whether the person died or survived, and it's whether they went by the helicopter or road. And I'm going to tell you, if you look at the ones that went, it says we see that 32%, or 64 out of 200 that went by helicopter died. Of course, right? So I'm just looking at that first table. Helicopter died. 64 out of 200, 32%. And then if you look at the ones that went by road and died, look, I'm not calculating all the conditional distributions, just the pieces I need to get my point across to you. There was 260 out of 1,100. And what's that percentage? They tell me that's 24%. So let me ask you, how do you want to go? I won't go by the road. Only 24% of those people died. 32% of the people who went by helicopter died. Right? I got 32 versus 24. Based off of that table, how do you want to go? I want to go by the road. Sorry, take me an ambulance. Yeah? Now, did we miss something here? Is there a lurking variable we might have, should have paid attention to? Like how serious your accident is? Yeah. So that's what they do. See, the variable here that they're lurking, that they're ignoring, is the seriousness of your accident. So now what they do is they take the original 1-2-way table and they make two of them, for serious accidents and for non-serious accidents. Okay? So you have serious, less serious. I'm going to calculate the same percentages again. The highway that died, the road that died. Now, they didn't add anybody to your tables here, right? They just took them and they just divided a 1-2-way table and they made two by the seriousness of your accident. Now, with the serious accidents, if you went by helicopter, 48 out of 100 passed away. I'm pretty sure that's 48%. If you went by road and died, was 60 out of 100. Okay, if you have a serious accident, how do you want to go? I want to go by the helicopter. So if you see me in a wreck, stop and ask the guy, hey, is this a serious accident? Yes? He wants to go by helicopter. Okay? Now, what about the ones with the less serious accidents? Let's see there. So we're going to do the helicopter. Died. Road died. Helicopter, how many died there? 16 out of 100? 16%. The road and died was 200 out of 1,000. Okay, how you want to go now? I won't go by the helicopter again. Now, did that reverse what we thought on the previous page? Yeah, when you ignored the seriousness of the accident, you thought you should go by road. As soon as you pay attention to that, as soon as you brought that lurking variable into the problem, and instead of having 1-2-way table, you had two, now the helicopter appears to be the way to go. Look, what's wrong with all this? How does this work? Why does this work like this? When you combine them all together, why does it look like the road is a better way to go? Does everybody see that in the original 2-way table, there was only 200 went by a helicopter and there was 1,100 of them that went by road? There were so many more that went by the road. Right? I mean, that's the deal here. And then when they break them apart, I'm not shocked that we flipped exactly what we thought was true. Right? We went from going by road to going by the helicopter. This is Simpsons Paradox. When you ignore a lurking variable and you combine groups that should have been paid attention to, you'll get one relationship. But as soon as you pay attention to that lurking variable, like the seriousness of the accident, it will reverse what you thought was the should happen, right? Here we know we should, look, you knew ahead of time you should be going by the helicopter. And if I would have questioned a little bit more, you would have told me, look, we always know that the people with more serious accidents go by helicopter, so when you combine them all, we're not shocked at a higher percentage of them died. But then when you break them apart, it's not quite the case now, right? That's Simpsons Paradox. And please remember, the lurking variable we're talking about, the variable that you're going to make more than just the one table, that's categorical, right? You're grouping things. You're sticking groups together in the original one that shouldn't be stuck together. That's the deal there. Now, as far as I'm concerned, that's the end of our story for the first 6 chapters. So, in my little thought here, we're coming to a changing point in the book. The first 3 chapters went together. We looked at one variable. The next 3 chapters, 4, 5, and 6, we looked at 2 variables. We went from 2 quantitative variables to this chapter here, which was 2 categorical variables. And so we skip chapter 7 because that's like a review chapter, and we go to chapter 8. So chapter 8 and 9, these two chapters go together for me. All right? And chapter 8, on page 203, the title of it is, Producing Data. Now, I'm going to go kind of slow and tell you what we're thinking about here tonight. Because up till now, all the data has been given to you in the problems. We hadn't had to produce any of the data. All right? We haven't had to do any of the sampling. We hadn't had to pick a group of people. Nothing. All right? Here's the thing about this. This is a big deal. When people argue about statistics, this is what they argue about. How did you produce the data? Nobody's going to argue about with how you calculated the mean. Hell, we all do that. We all add them up and divide by the total number. Well, what's wrong with what you're trying to tell me here is the way you produce the data. That's the problem. Because, to be honest with you, there's a right way to do this, and there is a wrong way to do this. And we're going to show you both. So, when I show you both, if you've done it the wrong way, then you don't trust anything we tell you here. If you've done it the right way, then we trust what's going on here. All right? Now, here's the way this works. I'm going to give you the question that they give us here. All right? And my question is, see, this is where statistics starts. Yeah, I know we started with graphs and calculations and all that stuff. This is where it starts. It's producing the data. But we have a question like this. What percent of college students think that? Now, over the next 2 or 3 classes, can you give me a break on any political thoughts you have? I just need some shit to talk about. I mean, I don't mean to be political. Like, if all of a sudden I start talking about the president's approval rating, I mean, I don't really care if it's 52% or whatever it is. I just need something to talk about here. All right? I don't have a view one way or the other. I mean, if you want to argue politics and stuff, you got the wrong guy. It's just I need to have something to talk about, and those are nice things to talk about. All right? So here I've got what percent of college students think that people should not obey laws that violate their personal values. That seems like a hell of a question we could have a long talk about. I don't care what you think about that question. That's not what that question's up there for. All right? Now, I'm going to underline something I'm going to circle something for you here. You see these people here? Does everybody understand that if I want to know something about college students, there's a whole bunch of them? Millions? My question is, can I actually talk to every college student and ask them this question? No. See, that's the problem. In statistics, there's always this gigantic group we want to know something about. But the group is so large that we don't have the time, we don't have the money, we don't have the people to talk to all of them. Right? Now, do I still want to have some thought about this question? Yes, I do. But I can't ask all college students. That's just impossible. Okay? So, once you get that stuck in your head, what we're going to do is we're going to ask a sample. Now, I've already read that word in a couple problems to you tonight. Right? Chosen to represent the entire, in this particular question, student population. In other words, we're going to choose a small group that we want to represent the large group. I want to choose a small group of college students to represent all college students. This is the way statistics goes. There's two definitions here. We got to know what a sample is. We're going to give you like a more formal definition, and we got to know what the population is. Well, what Chapter 8 is about, Chapter 8, producing data, sampling. What it's about is how do we choose the sample from the population. How do we do that? What is the correct way? Because remember, it's not just choosing the sample from the population. It's choosing the sample so that it represents the population. It looks like the population. It smells like the population. It tastes like the population. The only difference is it's smaller. We can deal with them. We can do our work there. We can ask them that question. All right? So that's Chapter 8. Now, you flip over here, and they're going to tell me about population versus sample. All right? And, all the questions we come up with here, right, from here on out are questions about some population, some large group. The problem is, again, we want information on this large group, on this population. It's too big. You can't deal with everybody. So you're going to choose a sample, and we're going to do our work in the sample. So what I would like to do is this. On page 204, right, there's 3 definitions there. And I'm not going to write the definitions for you, but the 3 definitions is, one of them's population. And it says, the population in a statistical study, all right, is the entire group of individuals about which we want information. So when I think about the population, this is where we want information about this group. This is a large group, like maybe millions of individuals here in your population. 2, your sample. All right? It says the sample is the part of the population for which we actually collect the information. We use the sample to draw conclusions about the entire population. Okay, the sample, we do our work here. This one is smaller. Hopefully that's a smaller group. The sample is not going to have 1 million people in it, 1 million individuals, 1 million objects, 1 million whatever we're looking at here. Okay? And then there is what's called a sampling design. Describes exactly how to choose a sample from the population. So there's a third thing. And we like to talk about sampling design. And I think about it like this. How the sample was chosen. How'd we do it? We have good sampling designs and we have bad sampling designs. And they have names. And there's ways that we do it. And that's how you recognize what kind you're looking at on how the sample was chosen. Now, here's the way I think about this, because you're going to get tired of me doing this to you. So anytime I talk to you about population and sample, population's always up here for me. This is the large group. This is the group that you want information about. Problem is too big. Can't deal with them. Time, money, manpower, nothing. So we need to come down here to the sample, right? That's where we do all our work. That's the reason I say that, right? This is a smaller group. So here's the way I think about it. Here's my population. And I'm just going to do this. There's a question I want to answer about a population, or there is some kind of information I want to know about this population. So I just put a question mark. What we want to know about, whether it's a question or whether it's information, is about this large group of individuals. This large group we're looking at here, all right? Too big. No time, no money, can't do it. Just too many people. So then we come down here to this is your sample. Okay? Now, whatever question you had about the population, you still had the same question, but it's about your sample now, right? So down here we answer the question, or we gather the information we wanted to know about the population. We do that in the sample. We do our work with the sample. Now, how do we get from here to there? That's the sampling design. That's chapter 8. How did you get from the population down to the sample? Now, I'm going to change colors on you 1 second here. And what you're going to hear me beg about this is when I go for the population and I try to choose my sample, when I try to get this sample, what we want to make sure is the sample is representative of the population. I want it to be made up the same as the population. I just want it to be small enough for me to deal with it. That's where we're at here in Chapter 8. You got a population. I got a large group I want information about or I want to answer a question about. Too big. I need to choose a sample, right? I need to do some sampling design that will get me this smaller group that I can do my work on, answer the question there, get the information there. I want my sample to be representative of the population that I started with. Now, there's another arrow that goes on here. The last 6 chapters that we deal with in this class, right, is about going from here to there. Okay, you had a question about a population. You chose a sample. Your sample was representative of the population. You got your information here. Now, I want to take what I learned from the sample, and I want to go back and say something about that question about the population. Now, all I'm going to give you tonight is this little arrow here is statistical inference. Or sometimes I'll just say inference. And what it means is to infer back about the population what you learned from the sample. To draw conclusions about your population based off of what you found out about your sample. That's statistical inference. That's inferring back from the sample back to the population. That's the last 6 chapters we do. We don't start anything about statistical inference until chapter, I think it's 13. Hell, it might be 14 in this book. And that's what we end up with is, how do you do that? How do you spend all this time going from the population to the sample? You got an answer here. How do we say anything about the question that you started with? All right. Now, a couple warnings here. When I think about this idea of representative sample, okay, choosing a representative sample. Now, I'm going to give you things that you're going to say, oh, well, that's like a stupid thing for you to say. Yeah, that might be. Okay? But my thought is this. The first thing, before you ever try to do this and attempt this, you need to know what is the population. Who are we looking at? Who are you trying to choose your sample? Where was the question? What was the question about to start with? So I'm going to go back to what we were just talking about. All right? Where I'm talking to you about college students. So what do we mean by college students? Do we mean full-time students? Undergraduates? Do we mean graduate students? Do we mean part-time people? Do we mean people just going at night? We mean people taking 3 hours? What do we mean by college students? That's what I mean by what is the population. Who are you looking at here? The reason I am concerned about this at this point right? And so when I think college students, hell, I'm thinking of all of them, part-time, full-time, undergraduate, graduate students, all of them, right? We want to know about all college students. So then those actually, if that's how your population is, then those folks have to be in there when we start choosing the sample, right? You can't start telling me that when you think college students, you're looking at undergraduates, and then when you go back to draw a conclusion, you're only drawing a conclusion about undergraduates, right? Because that was your population to start with. That's the reason this is important to me is I got to know what group I was choosing from so that I know what group I can draw conclusions about. You know, if I'm looking at, let's say, females aged 20 to 29, and that's the population I'm interested in, and I get down here and I get a sample and I get an answer about them, do I get to say anything about males 20 to 29 based off of that? No, hell no. That wasn't your population you started with. That's what I mean by what is the population. And then number two, this one may even sound stupider than that one. What do we want to measure? Look, all I'm asking you is, what's the variable? Or variables you're interested in. Well, back there it was their belief about people not obeying laws that violated their values, right? That was what you were interested in. That's your variable. I mean, I'm thinking we asked that question. It's a yes or no answer, right? We're looking at a categorical variable there. You know, what are we wanting to measure? And my warning is, and the only reason I write this down is, whatever you want to know about the population, whatever that variable is you want to measure, whatever that question is you want to answer, that's what you do in the sample. Right? That's what you do in the sample. That's the question you ask in the sample. That's the variable you want to measure in your sample. Now, here's the deal. All right? It's a little screwed up on how we attack this, but instead of showing you the right way to do it, we show you the wrong way to start with. Yeah, I know. And the first thing is how to sample badly. Oh, I'm using the words the book is. And what I'm thinking is bad sampling designs. How about you don't want to use these? All right? And so the first one here is an example 8.2. All right? And it says, a sample of mall shoppers is fast and cheap. Oh, we love stuff that's fast and cheap. But people at shopping malls tend to be more prosperous than typical Americans. Is that true? I mean, hell, they are at the mall, right, buying something. They are also more likely to be teenagers or retired. Is that true? It's been a long time since I've been to the mall. So they're either young or old? Okay. Moreover, unless interviewers are carefully trained, they tend to question well-dressed, respectable-looking people and avoid poorly dressed or tough-looking individuals with biker jackets and tattoos and stuff like that. All right? The types of people at the mall will also vary from by time of day and day of the week. In short, mall interviews will not contact a sample that is representative of the entire population. Now, when they say the entire population here, what they're talking about is, I'm going to guess, the entire American population. Going to the mall and sampling there will not produce a sample that's representative of the entire American population. The problem with this, and what this is called is, it has a name, and this is called a convenience sample. It's the easiest to reach. This is not good. That's bad. Okay, if you don't like the mall thing, suppose I want a sample of ETSU students, right? So I go to campus. Oh, I have a reason for pulling this out. Let's say I want a sample of ETSU students. Yep. So I go to campus and I stand in front of the library. I select the first 20 that come to me to ask them my question. You think that sample is representative of all ETSU students? That's definitely convenience sampling, right? Or, I don't know, that's probably the best one I got there for convenience sampling. When you sample the easiest people to reach, your sample is not representative of whatever population you're looking at. Now, I'll give you this. If you're interested in what people at the mall think, you going to the mall and actually sampling them, that's okay. Right? Those people were at the mall. If you want to know about ETSU students, don't go stand in front of the library and talk to the first 10 that come by you. All right? If you want to know about the entire American population, you don't go to the mall and start asking people the question, whatever question you're interested in there. Now, I got one more, and we'll pick up there on Thursday. Right? The first bad one's convenience sampling. That's the easiest to reach. We'll pick up. I got another one, bad one, then we got good ones. You'll get to talk a little bit about chance. I'll try to stay away from the word probability. Everybody be careful going to the house. We'll see you on Thursday.